be learning about ledgers, blocks, transactions, and wallets in blockchain in this session. Let us start with ledgers. All blockchains are distributed ledgers, but not all distributed ledgers are blockchains. This is an important statement. We need to know that distributed ledger technology is the backbone of any blockchain network. But distributed database is not a new concept. It has been in use for decades now, and therefore the above statement. When other properties like cryptography, consensus, blocks, smart contracts, etc. are applied along with distributed ledger technology, we start building a blockchain network or application. Blockchain data structure can be described as a back-linked list of transactions arranged in blocks. They can be stored in simple databases or in the form of flat files. Each block is identified with the help of hash in the block header. Each block references a previous block, also known as the parent block in the previous block hash field of the block header. In simple terms, blockchain database is literally a chain of blocks, a linear structure starting with the so-called genesis block and continuing with every new block added to that chain. Only one chain of blocks is formed with any shorter side chains or branches discarded. Each block contains a number of transactions and is referenced to the block before it through the hash. This way, all blocks in the chain can be traced back to the first one and no modification to the data on the block is possible. Next, we look at blocks in the blockchain. Let us start with a similar example that we might be used to from our day-to-day banking. Consider taking a look at your bank account statement from the time your account was created till the present day. Every time you performed a transaction, the transaction details were updated in the passbook. So, your passbook is synonymous with the blockchain, and the transactions that were performed in one visit symbolizes one block. The next time you do some transactions, this new set of transactions get appended to the previous list of transactions. These new set of transactions can be seen as the blocks that will get appended to the previous block, which is nothing but previous list of transactions, thus continuing to update the passbook, or we can say blockchain. The passbook example was kind of generic representation of forming the blocks and in turn the blockchain. Let us now start with the content of a block in the blockchain. To understand the structure of a block, we use the example of a block in Bitcoin. However, the concept of blocks in any blockchain will remain more or less the same. A block is a container data structure composed of a header, a transaction counter, and a long list of transactions. Block header contains the metadata about a block. A block in a blockchain is identified via the block header hash. So block header hash is like an identity card for a block in the blockchain. Block header hash is determined by applying it through the SHA-256 algorithm twice. So what are the components of a block header? Technical data. It includes a version number and size of the block specific to the Bitcoin. Version number specifies the set of protocol rules to which the block conforms to that was set while conceptualizing the Bitcoin. Previous block hash. It contains the hash of the previous block in the blockchain. This hash is the link that creates the chain of blocks. Merkle root. It is a hash value which basically is a distillation of all the transactions in the current block into a single hash. In simple terms, it is like a tree that helps locate the right transaction when searched. Timestamp. It is the timestamp of the block when it was created. difficulty target, the number of zeros that must be found when hashing the block header. In Bitcoin, the block creating rate is every 10 minutes to ensure a constant output. To ensure that the mining rate is maintained around 10 minutes, the network modifies the difficulty target proportionately to maintain the desired time interval. Nonce, the value that is altered to try different permutations to achieve the required difficulty level. Summarizing the above, a block header hash is equal to double hash or hash of technical data plus previous block hash plus Merkle root plus timestamp plus difficulty target and nonce. Next is transaction counter in a block that indicates the number of transactions in that block. Please note that the maximum number of transactions in a block is a fixed number. As soon as the maximum number is reached, the new block is generated. Transactions. A transaction in Bitcoin is represented as the technical data, which is related to the number of inputs and outputs in this transaction. Inputs contains the details about which Bitcoins are being considered for this transaction and private key to sign this transaction.